So let me present the main principle of general equilibrium models. And in order to do that, I would like to start with reminding you what was the main principle of partial equilibrium model. So you remember that in partial equilibrium, when we studied a specific sector, we were supposing that factor prices and consumers' income were constants. Well, right now, under general equilibrium, we do not suppose that factor prices and consumers' income are constant. In fact, we try to take into account, when we study a specific sector, what also happens on the factor markets and what happens in terms of incomes of consumers. And in fact, we take into account all markets and variations in all prices and incomes. So for example, if we study the oilseed markets, we do not suppose that the land market and the labor market is in equilibrium and that factor prices do not change. We do not suppose that consumers' income are constant and so on. In fact, we take into account what happens, the impact of what happens on the oilseed markets on the labor market and the land market and on consumers' income. And we take into account the feedback effect of these changes on these markets on the oilseed markets. So under general equilibrium, we take into account interdependence between markets, and we take into account equilibrium on all markets. And so this is the main distinction between general equilibrium and partial equilibrium model. So it means that the general equilibrium is more consistent in terms of approach, but of course it is at the same time more complex and more demanding. You remember that in the partial equilibrium model, we used to represent a sector with quantity on the horizontal axis and price on the vertical axis. And we used to draw a demand curve decreasing with price and a supply curve increasing with price. And in fact, the assumption behind that was that, in fact, demand for a good only depends on the price of this good, and supply of a good only depends on the price of this good. And we can in fact suppose that all other variables in the economy were constant. Under general equilibrium model, it's very difficult to do that because in fact we take into account the fact that demand for a good depends not only on the price of this good but also on consumers' income and all other prices. Why? Because in fact, demand for a good is expressed, for example, by a household, and this household has a budget constraint, and so we have to take into account consumers' income, but we have also to take into account all other prices. Of course, the price of substitutes, the price of complements, but also the fact that if the general level of price is very high, the purchasing power of the consumers will be low. And on the other side, if the general level of price is very low, we can suppose that the income of the consumer will give him more purchasing power. And we also have to assume that supply of a good depends on the price of a good, but also on factor remunerations and price of intermediate goods, because in fact, supply of a good depends on the cost of production, and the cost of productions includes the remunerations of primary factors, but also the cost of purchasing all intermediate goods. So let me tell the basic principle of general equilibrium models. So the basic principle is that equilibrium on one market depends on equilibrium on all the other markets. Why? If we look at, for example, the same example, the oilseed sector, what happens in this sector depends on supply and demand in this sector. But supply in this sector depends on the cost of production, so the price of all inputs and the remunerations of production factors. And so it depends on what happens on the labor market, on the land market, and on the markets of all potential inputs. And demand depends on income of consumers, but also maybe it depends on activity in other sectors, which buy oilseed, for example, to make biodiesel, and so on. So the basic principle of general equilibrium models is that there is an interdependence between all markets, and so equilibrium on one market depends on equilibrium on all other markets. And so it means that we cannot suppose in general equilibrium models that prices or income are constant. All prices and all incomes may vary. And so we have to take into account this principle in the understanding of general equilibrium model. And so an implications of that, which is really important, is the fact that if there is one market in disequilibrium, it means that there is another, at least, market which is also in disequilibrium. Why? Because, in fact, if one market is in disequilibrium, it means that, in fact, there will be an equilibrium process in this market by variations of price. And so it means that it will affect other markets because there is an interdependence. And so it means that the equilibrium process on at least another market is not over. So you have to understand that. And so a direct implications of that, which is really important and that you have to keep in mind, is the fact that if you have n markets and if there is equilibrium on n-1 markets, it means that there is also an equilibrium on the last market. And this is really an important implications of general equilibrium model. This is what we call the Walras's law. So what I would like to do right now is to give you a simple illustrations of general equilibrium model. So I'm going to present a simple model in general equilibrium. In fact, there will be only 8 equations and 8 variables. You see that it's very simple. So it's a basic model, and of course it will be the object of modifications in the next videos. But right now we have only 8 equations and 8 variables. So what I'm doing here is that I'm adopting an incremental approach. I start with something very simple, and then I try to complexify, in fact, the representations of economy. And I would like to emphasize the very important property of general equilibrium model with this model, which is the interdependence of markets. Okay, so this is the main objective of this video and this model. And there is also another important aspect that I would like to emphasize, is that there is underdetermination. So it's a mathematical difficulty that we have to solve. And I will explain how to solve this underdetermination. So I'm going to present a model, very simple model of an economy in general equilibrium. So we suppose an economy with a single agent, without government and without relations with the rest of the world, and there is no investment. So you see that there is many simplifying assumptions. So production gives birth to remuneration, of course, and the income is fully spent on consumption, so it means that there is no saving, and an explanation would be that there is only one period of time, so there is no need to keep money for future periods. The production technology is Cobb-Douglas, so you know what is a Cobb-Douglas, and capital is associated to labor in this production process, and there is the production of a single good, so only one good. And so, of course, because of production associates capital and labor, which are productive factors, an income is given to the owner of this productive factor who is the single agent, and this single agent owns productive factor, so it's normal that he receives the income from production. And last assumption, the fact that all markets are balanced thanks to price variation. And of course, you've got three markets: output, capital, and labor. So you've got three markets that will have to adjust through variations of prices. So what we do now is that we design a model with a single agent, a single good, a Cobb-Douglas technology, associating capital and labor, no savings, no investments, no government, no relations with the rest of the world. So this is a very simple economy. So we need a few annotations for the endogenous variables. Here we have 8 variables. So let us call KD the demand for capital, LD the demand for labor, Y the productions of the unique good, INC the revenue derived from productions and given to the agent, C the demand for the unique good by the agent, P the price of the good, R the remunerations of capital, and W the remunerations of labor. So we have only 8 variables. This is related to the assumptions that I presented earlier. We could have something, of course, more ambitious. For example, we could have labor supply and capital supply endogenous, that is to say, explained by the model. So, for example, in the case of labor supply, it would need an equations explaining how labor supply can vary, for example, in functions of the real wage. If we also have capital supply endogenous, we would have 10 equations and 10 variables. But this is not the case here. We have only 8 equations and 8 variables. So we have other annotation needed by the model. So let us also call KS capital supply, LS labor supply, alpha the elasticity of productions with respect to capital, and A the global productivity of production factors. So in fact, KS, LS, and A are exogenous variables. That is to say, they are something that can vary, but this is exogenously decided by the modeler. In fact, these are variables that are not explained by the model. If they vary, this is decided by the modeler as a shock, and this is not explained by the model. In fact, for example, the modeler can decide to introduce some technical progress and can decide to augment A, the global productivity of production factors, or he can decide to introduce immigrations with an increase of LS, or he can decide to introduce foreign direct investment through an increase in the capital supply. Alpha is the elasticity of productions with respect to capital. So it is something which is a parameter. It is in fact the result of an econometric investigations or a review of literature. So it is not supposed to change. So what we just did is to suppose that capital supply, KS, and labor supply, LS, and global productivity of factors, A, are exogenous variables. And we also decided that alpha is a parameter. So what we have is that we have 8 endogenous variables: KD, FD, Y, INC, C, P, R, and W. And so we need 8 equations for a square system. So let us find out which are the equations that we need for a square system. First, if you remember the assumption, we supposed that technology is Cobb-Douglas, so it means that we've got an equations of productions, which is a Cobb-Douglas technology. Y is equal to A times KD at the power alpha times LD at the power 1 minus alpha. So this is the Cobb-Douglas technology. What we can do is that we can derive from cost minimization demand for capital and labor. So we've got two equations. So from cost minimization, first a demand for capital, which is alpha times P times Y is equal to R times KD, which is obtained through a cost minimization program. And 1 minus alpha times P times Y is equal to W times LD, which is the demand for labor. Well, once we have this production block, in fact, we've got revenues from production and we have the formations of the agent's income. You remember that the agent is the owner of productive factors. So the productive factors are in quantity LS for labor and KS for capital. So if the agent is the owner of productive factors, we can derive an equations of formations of income, which is INC, the income, which is equal to W times LS plus R times KS. Then with the income, the agent can proceed to final consumptions. So there is no savings because there is a single period of time. And so to maximize satisfaction, in fact, he has to maximize consumption, which is only limited by the level of income and the level of price. So it means that the agent's consumptions is P times C is equal to INC. Then we've got the final block of equation, which is equilibrium of markets. First, on the good markets, this is equation 6, C is equal to Y. KD is equal to KS, this is the equilibrium of the capital market. And equation 8 is LD is equal to LS, this is the equilibrium of the labor market. So here we've got the program, the model, and we've got 4 blocks. The first block, which is a production block with equation 1, 2, and 3. Then the second block, which is formations of income, which is equation 4. Then we've got the agent's consumption, so this is equation 5. And a final block, which is the block of equilibrium of markets with equations 6, 7, and 8. So what we are going now is to do an exercise, which is to allocate each equations to the determinations of a specific variables. This is not mandatory to do that, but it's interesting for at least 3 reasons. First, it is interesting from an intellectual point of view in order to improve our understanding of the model. Second, because in the case of potential extensions, we have to understand that we need, if we want to endogenize one variables, we need a specific equation. So for example, if we want to endogenize labor supply, we need an equations which explains how labor supply can vary. And third, in the case of a way of programming, which is MCP, we need, in fact, to allocate each equations to the determinations of a specific variable. So let us do that in the case of this model. So the first equation is obviously an equations of production, so it's an equations which determines the level of output Y. The second and third equations are equations which are derived from a cost minimization program, and we minimize cost in order to determine the demand for productive factors. So the second equations is an equations which determines KD, and the third equations is an equations which determines LD. Then it's obviously in the case of equations 4, because in fact we have a formation of income, so it means that is an equation which determines INC. And then the fifth equation is obviously something which determines C, because it's the derivations of final consumptions from a utility maximization program. And then we've got equations 6, 7, and 8. So here this is interesting because in fact these are equations which expresses equilibrium on the three markets, concerning 6 on the goods markets, 7 capital market, 8 labor market. So you know that an equation which is demand is equal to supply is an equation which determines a price. So we've got 3 equations that determine prices on each market. So equation 6 is an equation which determines P. Equation 7 is an equation which determines R. And equation 8 is an equation which determines W. So right now I would like to expose a problem that we have, which is really important, and this is something that will need a specific treatment, and this is specific to general equilibrium models. The problem is that we have 8 free variables in this model, free meaning that these variables can vary on a specific domain of definitions. So in fact they are positive. This is the only restrictions that we impose. But we have only 7 independent equations. Why? This is because what I'm going to demonstrate is that if equation 2, 3, 4, 5, 6, and 7 are verified, then we have equation 8 which is verified. So it means that equation 8 can be derived from equation 2, 3, 4, 5, 6, and 7. And so it means that the system is underdetermined. So let us demonstrate that we have one equation which is not independent. So let's start with equation 6, which is C is equal to Y. This is the equilibrium on the good market. So if you multiply by P, you obtain P times C is equal to P times Y. And in fact, you can multiply P times Y by alpha plus 1 minus alpha, because alpha plus 1 minus alpha is equal to 1. So you've got P times C is equal to alpha plus 1 minus alpha times P times Y, and so you can make distributions of P times Y, and you obtain a new equation which is P times C is equal to alpha times P times Y plus 1 minus alpha times P times Y. So with this equation we are going to include other equations like equations 2, 3, and 5. So equation 2 is alpha times P times Y is equal to R times KD. Equation 3 is 1 minus alpha times P times Y is equal to W times LD. And equation 5 is P times C is equal to INC. So if you use these equations and the equations that we've got earlier, you can in fact replace P times C by INC, and on the right side you can have RKD plus W times LD. So you've got a new equations which is INC is equal to R times KD plus W times LD. And with this equation, in fact, you can use right now equation 4 and equation 7. Equation 4 is INC is equal to W times LS plus R times KS. And equation 7 is equation KD is equal to KS. So if you use both equations, you can make some replacement in the equations that you've got earlier. So you replace INC by W times LS plus R times KS, and you replace on the right side KD by KS. And so you've got a new equations which is R times KS plus W times LS is equal to R times KS plus W times LD. So right now you can simplify by R times Ks, and then you can simplify by W because W is different from 0. So you can divide both sides of these equations by W, and you obtain an equation which is LD is equal to LS. So it means that by combinations of 2, 3, 4, 5, 6, and 7, we obtain equation 8, which means that equation 8 is not independent. It is derived from other equations. So this is what we call the Walras's law, which means that the system is underdetermined. So there is a problem with this model because in fact we've got 8 variables and only 7 independent equations. So it means that there is not enough information to find a solution. It's exactly like a mathematical problem with only one equation, which could be, for example, x plus 2 times y equal to 4, and 2 variables, x and y. So it means that, in fact, all the straight line defined by x plus 2 times y equal to 4 is solution of this problem, and we've got an infinity of solutions, and not only one solution. So it means that in our case of these small general equilibrium models, we have 8 variable and 7 independent equations. We have a model which is underdetermined, and we have an infinity of solution. So what is the solution of this problem? Well, what we are going to do is fixing a variable such that we have 7 free variables and 7 independent equations. The variable which is fixed is a price. So here either it is P or W or R. Let's choose W, okay, because this is the price of labor. Of course, you can choose the price of capital or the price of the good P. So here I choose W. This is the new numeraire. So it means that everything now is expressed in terms of unit of labor, and all prices will be transformed into relative prices. So we fix the variable W at its initial level, W0. Consider the case where we have normalized labor, that is to say, we've got a general amount of salary in the economy, which is so the price of labor multiplied by the volume of labor. So it could be 1 man during 1 year, okay? And the salary of 1 man, the annual salary of 1 man. We can change, in fact, this value of labor and adopt a new unit of labor, which is the amount of labor available initially for $1. So it means that the new unit of labor is the amount of labor available for $1 instead of 1 man during 1 year. And so it means that with this new unit of labor, the new initial price of labor is W0 is equal to 1. And so it means that we have fixed the price of labor, W, the endogenous variable. It remains now at its initial value, which is 1. So in fact, modelers used to keep the labor market equation or the good market equations or the capital market equation. They do not want to give up one equation. In our case, the model of an economy without a labor market equation would be a little weird. So we have to keep the labor market equation and to have 8 independent equations. And so it means that we must have 8 free variables. How to do that? Well, we can create new variables. This new variable, for example, we can call it Léon in honor of Léon Walras, but of course you can choose a different name. And we add this new variable into the labor market equation. So it means that the new labor market equations will be LD is equal to LS plus Léon. And this is really interesting because right now, remember that we have suppressed the variable W and we have just added a new variable which is Léon. So we have 8 free variables. So it means that the variable Léon can take any value. And we have an equation which is no more LD is equal to LS, but which is LD is equal to LS plus Léon. So it means that we have an independent equation because now 2, 3, 4, 5, 6, 7 do not imply LD is equal to LS plus Léon. In fact, equation 2, 3, 4, 5, 6, and 7 imply LD is equal to LS. So we've got now 8 free variables and 8 independent equations. So we've got a new model which is in fact slightly changed as compared to the previous one. We have 8 equations. The first equation is the level of production based on Cobb-Douglas technology. The equation 2 and 3 are the demand for capital and demand for labor by the productive sector. Then equation 4 is the formations of income, the income of the consumer. Equation 5 is the consumer's final consumption. Equation 6 is the equilibrium on the good market. Equation 7 is the equilibrium on the capital market. And equation 8 is the equilibrium on the labor market with the additions of this new variable, which is Léon, which we can initialize at 0, but which can take any value. And in fact, we will check if the Walras's law is verified if this variable Léon remains at 0. And we had restrictions, which is the fact that the variable W, in fact, is fixed at its initial value W0. So it means that we have 8 independent equations and 8 variables. Y, the level of production, KD, the demand for capital, LD, the demand for labor, P, the price of the good, R, the price of capital, C, the level of consumption, of final consumption in volume, I and C, the level of income, and Léon, which is this supplementary variable. So I give you now an assignment. So this assignment consists in writing the program that I've just exposed within a new GAMS file. And so you will need to define everything, declare everything, all the parameters in particular that you need for this model. And concerning this parameter, you need some initial data. So I only give you 5 initial data. So the supply of capital, 7,000, the supply of labor, 3,000, and the price of labor, of capital, and of the unique good, the initial prices, they are all equal to 1, which means that we have normalized labor, capital, and the quantity of unique good. And what I would like you to do is to study an augmentations of labor supply by 10% and an augmentations of capital supply by 10%.